Okay, hello everyone. We go over the problems now. So here, the first problem, we have a uniform solid ball placed at rest on an incline with an angle theta. So here is the ball, and it asks, what is the minimum value mu0 of the coefficient of static friction between the ball and the incline so that the ball will roll down the incline without slipping? Okay, so here there are several forces on the ball. There is gravity, which goes straight down, but then since gravity goes down, the component that goes down along the incline, well, since this would be mg, this would have to be mg sine theta. And then the component of gravity that is perpendicular to the incline going like this would be mg cosine theta. And then, of course, there is going to be a friction force. Since the ball is rolling down, the friction force is going to be pointing up the other way. And this would be mu mg times, would be mu times the normal force, which is mg cosine theta. So it would be mu mg cosine theta. Okay, so now, since we want it to be rolling without slipping, that means that the angular acceleration alpha has to be equal to the acceleration alpha over the radius r. So now we can try to find alpha. And since we know that alpha is just equal to tau over I, the torque over the moment of inertia. So now first we try to find the torque. And there is only one force that creates a torque on the ball, and that is this friction force, because all the other forces go through the center of mass. So then the torque would be the force mu mg cosine theta times the distance to the center of the ball, which would be r. And now the moment of inertia for a solid ball is 2/5 mr squared. You should, if you're going to be doing physics competition and stuff, it would be best to have this memorized, and you should also know how to derive it. And so this is equal to 5 mu g, so this would be equal to 5 mu g mg cosine theta over 2r. In fact, here it wouldn't be, it would be 5 mu g cosine theta over 2r. So then that means that this alpha is equal to a over r. So this means that a would have to be 5 mu g cosine theta over 2. Okay, so now there is another way that we can calculate the acceleration, which is just by looking at the forces on it. Since it's just going down the incline, then the only two forces that we need to consider are this mg sine theta and this mu mg cosine theta. And since they're going in different directions, this a would have to also be equal to mg sine theta minus mu mg cosine theta. And since this is equal to 5 mu mg cosine theta over 2, then this would be all be over m. The m's all cancel out. Okay, so then this means that g sine theta is equal to 7 mu g cosine theta over 2. So now we can just cancel out this g, of course, and then we're trying to find mu. So then mu would just be equal to 2 over 7 times tangent theta. And so that is the answer to the first problem. Does anyone have any questions? Okay, then I'll move on to the second problem now, in which we have two thin slits, as in the standard double slit experiment, and they're separated by a distance d, but one slit only emits light with half the intensity of the other slit, and we want to find the diffraction pattern in the far field limit from these slits, which basically just means that we want to find what the intensity is proportional to. That's just what we're trying to find. Okay, so to find the intensity, we add, so for the solution to the wave equation, we have this A sine omega t minus kx. And so our first step to find the intensity is, well, we know that this intensity is proportional to a squared, I believe. So then, but obviously we need to express this in a different form for this problem. And so to find this, we first take this A sine omega t minus kx. And since there are two slits, both with light coming out, we need to add this value for both of them. And the phase difference between them would just be k d theta, where would just be k d theta, where k is the wave number and theta is the angle that is created between the two slits and the distance. So then we just add them together. Since the phase difference is k d theta, we can write it as a sine omega t minus k d theta over 2 plus a sine omega t minus plus k d theta over 2. So now the phase difference would be k d theta. But since we know that this intensity for the second slit has been halved, that means the amplitude A would have been divided by square root 2. So then this would be A over square root 2 times this. And to simplify this, we can use sine A plus B is equal to sine A cosine B plus cosine A sine B. And so then applying this, we would get A times sine omega t cosine k d theta over 2 minus cosine omega t sine k d theta over 2, and then plus A over root 2 times sine omega t cosine k d theta over 2 plus cosine omega t sine k d theta over 2. And so now we can collect some like terms and simplify, and we should get this is equal to A times 1 plus root 2 over 2 sine omega t cosine k d theta over 2, and then plus it would be minus, actually, minus A times 1 minus root 2 over 2 times cosine omega t sine k d theta over 2. And so now once we have this expression, to find the intensity, this omega t, the sine omega t and cosine omega t only have to do with the time difference. And since this is like a far field limit, we only care about like diffraction patterns based on theta. So then we can just ignore that. And so we know that it should be, I should be proportional to like a squared, and then like there should be another value, which is cosine squared of this phase difference, k theta. And so since we have two of these, we basically just take the average. And so then it would be I is proportional to a squared cosine squared k d theta over 2. And we're only taking the average of this, and then so that would be plus oh yeah, I forgot. There should also be multiplied by 1 plus root 2 over 2 squared, and that would be 3 over 2 plus root 2, I believe. And then plus a squared times sine squared. It's just the term with the kd theta over 2 times 3 over 2. Yeah, plus 3 over 2 minus root 2. And so, yeah, so then we have some terms. We would eventually get, I believe, one, I is proportional to, it says, so now once we have this, it would be like a squared times something like 2 root 2, 2 root 2 cosine squared k d theta over 2. And then plus, I believe it would be plus minus 2 root 2 plus 3 over all over 2. And so, yeah, there is an answer key for this, and it gets something different. It gets plus 1, and there is an a squared term, but I believe that is just a typo. So yeah, that is the answer to the second problem. Does anyone have any questions? Okay, if not, then that's it for me, and thank you for listening.